Hi, and welcome to my classroom. So, the purposes of this particular recording is to give a quick recap of what has been learnt so far in my classroom. So, we started off by looking at the very basics. Now, I told my class that in order for us to build on top of our knowledge, we have to make sure that all of the foundations are understood. So in year seven, we normally touch on and talk about what is matter and what is it made up of. So there are two categories that stem off matter we have in this particular flow chart: pure substances and mixtures. So pure substances are made up of elements as well as compounds here. So an element is found in our periodic table and it's something that is made up of its purest form. So let's say gold, it is only made up of gold atoms. You can find it naturally occurring in our environment. So I can't come along and just magically create gold. Um, with mixture on the other side over here, we can find them also in two categories: homogeneous mixtures and heterogeneous mixtures. So homogeneous mixture is a combination of my compounds, and I may find elements there as well floating around. Whereas heterogeneous mixtures, as you can see, they are not mixing as such. Okay, so then we looked at two separate categories, so molecules of elements and molecules of compounds. So if I have a molecule of an element, of molecules of elements, I've got two of each, for example, or more, but of the same kind. So I've got molecules of hydrogen, a molecule of oxygen, a molecule of chlorine down the bottom, and I can compare it to a molecule of a compound where it has more than just one kind of element. So I've got a molecule of water and I have on the bottom a molecule of hydrogen chloride made up of the chlorine atom and the hydrogen atom. So if I look back at my periodic table and the atom itself, I can see that an atom is the smallest unit of matter. So I compare this to your standard textbook example of a Lego piece. So my Lego piece is a building block, and if I want to create a kingdom, well, I need to use those building blocks. I need to have lots of those small Lego pieces to create my mansion or my plane or my fire truck, for example. Okay, so my periodic table is made up of lots of symbols and lots of different numbers that are next to this particular symbol, and this particular one over here I've given to you is of helium. Okay, so I've got two numbers here, and the number 4 is the larger number on my periodic table. That is referring to my mass number, and that is giving me and telling me the total number of neutrons and protons there are in that particular element. Okay, and the smaller number is my atomic number, and so that's telling me the number of protons, which is equivalent actually to the number of electrons in my particular atom. Okay, so we can draw the structure of the atom by using the Bohr model. Okay, and so you can see that now as they've drawn it here, my atom is actually made up of even smaller subatomic particles. So even, there are other actual components within my building block, and those subatomic particles that I refer to as protons, they are positively charged. Then I have neutrons, which are neutral, as the name suggests, and finally I have electrons, which are negatively charged. So then we also, let's move back and have a look at this particular worksheet. So they, it was expected to fill out the different charges of each subatomic particle. Definition was provided for what is a atomic number and what is a mass number. And then we also looked at the rule over here, that this information actually gives us the ability to find the number of protons, neutrons, and electrons for atoms in various elements. Okay, this rule here, though, it's referring to elements that are above 20. Okay, so anything that has more than 20 electrons. So if I have an atomic number of 22, then I can use this particular rule. Anything that's below 20, though, doesn't actually apply. Okay, so let's have a look at the actual calcium atom, which has the atomic number of 20, has a mass number of 40. If I want to find the number of neutrons, well, I can go atomic mass being 40, take away the number of protons, which is 20, then I'm left with 20 neutrons. So if I want to draw it or write out the electron configuration, well, I start off by filling up the first shell with 2 electrons because that is the total capacity that it can hold. And from there on, I'll continue counting on and fill up the second shell, which can only hold 8 electrons. So from 2, I count on 3, 4, 5, 6, and I keep going until I have filled up the second shell. Then I can see, well, okay, I filled up the second shell, but I still have electrons left over. So then you fill your third shell again, which can hold only a total of 8 shells in this case, okay, electrons, sorry. And so I fill that up with 8, and then I'm left with 2, so that will be drawn on my very outer shell. Now, this particular model I have prepared for you earlier. Okay, so the green over here that I have is referring to the electron clouds. In the center, I have written, well, my atom has an atomic number of 5, so it has 5 protons. And so if I have 5 protons, that I know that the element is boron. Boron also has 6 neutrons, so that's why I wrote it in the center. And because it has 5 protons, I know that it has a total of 5 electrons. So when I was drawing this, I started off by drawing the first shell. I filled it up with 2 electrons, 1 on each side. Then I drew a second shell because I had 3 electrons left. And what you normally need to, or what I do, what I tell my students is to draw those electrons in pairs. So I've gone, okay, so I've got 2 in the center, 2, 3, 4, and then I have 1 left over. So these red arrows over here are actually pointing that you don't have to actually draw them exactly where I did. You know, though that pair could have been drawn on the opposite end or on the bottom. And then finally, that red dot is showing where I could have potentially drawn my other electron that unfortunately doesn't have a pair in this case. Okay, so in order for an atom to be stable, atoms like to have a full shell. So it likes to have a total of 8 electrons. So we've actually spoken about and looked at what ions are and, you know, how do they form, and you know, we even did an experiment detecting ions by indirect observations using common household solutions that we can find around, you know, anywhere, basically coffee, oil, etc. But going back to what I'm speaking about right now, so, you know, if I want, if so, an atom wants to be stable. So the octet rule basically is talking about 8 valence electrons in its outer shell. Okay, so metals generally lose electrons. So when it loses, you can see it's going to become more positive because it now has it has less electrons. So that's going to be referred to as a cation. Non-metals gain electrons, and so, you know, it's going to form an anion because it has more positive, sorry, when it gains electrons, becomes negative because now it has less, sorry, of those protons. Okay, so I have my sodium atom, it's losing an electron, whereas my chlorine atom is gaining an electron, and they're going to become more stable because now I have a total of 8 valence electrons in chlorine. Okay, so hopefully that makes sense. I have also created a revision worksheet for my class that they'll go through and make sure they, you know, keep calm and do some revision. Thank you.